all lives. They're all lives. Okay, so the word empirical literally means from data. And when you're doing experiments, the empirical formula is what the data is going to give to you. The molecular formula is the actual number of atoms in a compound. Now, they're different because the empirical formula is always going to give you the reduced form. If you're looking at a compound of N2O4, the empirical formula of N2O4 is NO2, and that's what the experiment is going to kick out. It's going to kick out the empirical formula. It won't kick out the molecular formula necessarily. Okay. So sometimes the empirical formula is the molecular formula, and sometimes the empirical formula will have to be multiplied by 2, 3, 4 to get the molecular formula. For instance, if you did an experiment and it kicked out that the empirical formula was NO2, but it also told you that the molar mass was 96 grams per mole, that would mean you're not looking at NO2, you're looking at N2O4. Because NO2's molar mass is 14 for the nitrogen and 16 times 2 for the oxygen. 32 plus 46? 46? 46. So, 92, how about 92? 92, there you go. So I have to do your math in your head. So if you have a compound and you're sitting in front of a compound and the data kicks out and it says the formula, the empirical formula is NO2, but you know the molar mass is 92, then you know this is 14 times 2 plus 16 times 4, that's 64 plus 28. Is that 64 plus 28 is 92? Yeah, 92. So what you're actually looking at is N2O4. Now C6H12O6 is glucose, a simple carbohydrate your body likes to make, and you'll learn all about it in biology. If you put glucose through a lot of tests, it's going to get kicked out with an empirical formula of CH2O. Now CH2O is not glucose. This is glucose. So the empirical formula will always be the simplest form of the molecular formula. And the molecular formula will always be a multiple of the empirical formula. Okay. Does that idea make sense?
Yeah.
Okay. Hopefully we actually do some concrete examples that'll make more sense. Now let's talk about percentages. Specifically, percent compositions, also called mass percent. Now, if you want to find a percent of something, how do you find a percent of something?
Divided by 100.
It's a ratio. What is it a ratio of?
Fraction.
Exactly. Percent is a ratio of the part over the whole. For instance, if we wanted to know what percent of females are in the classroom and what percent of males are in the classroom, what would we do? We count it. So let's count females. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 females. Did you just assume my gender?
Yeah, I think you did.
Over an overall class size of. We lost 2. So in today's class there are 34 present. 34 present. Okay, 34. And that would mean the males are 18 over 34?
No, 17 and a half.
Fair enough. Okay, so I don't know what the math is. We can ask Alexa what the math is. Alexa, what is 16 divided by 34?
16 divided by 34 rounds to 0.471.
So 47.1%. And that would mean this would be about 53%. Let's go ahead and round it 47%. Make sense? Okay. So when you're doing a percentage, it's always a part over a whole. Now if you look at a water molecule is 2 hydrogens and 1 oxygen. If you wanted to know, and I frequently do, what is the percent of hydrogen and what is the percent of oxygen? This is how you do it. You look at how much of a mole of H2O is hydrogen, and in a mole, you have 2, which is 1 times 2. Where did the 1 come from for hydrogen?
Periodic
Exactly,
table.
periodic table. Periodic table tells us that 1 mole is 1 gram because it has a 1 for the mass, and there are 2 of them. And oxygen, if you find oxygen on the periodic table, what's oxygen's molar mass? 16. So in 1 mole you got 16 grams, and the total for both of these would be 18. And you can do this math to figure out what is the molar mass, or sorry, what is the percent composition of hydrogen in water and how much is oxygen. In other words, when you're drinking some water, you're like, oh, that's some good water. Of that water, this percent is hydrogen, this percent is oxygen. Anyone know what those are? 1/9, does anyone know what 1/9 is off the top of your head?
11.11%.
Yeah, exactly, 11.1111, 11%. And this is 89.989, yeah, 89%.
Like, mostly oxygen.
88.88888888.
In weight.
Yeah. So it's,
Not the
nines are fun. 1/9 is 11.111, and that's 8.8888. So 88. So if we said, how much of that water you're drinking is hydrogen? Well, 11% is hydrogen. How much of that water you're drinking is oxygen? Well, 89% is oxygen. Does this make sense?
Yeah.
So give me a thumbs up if you understand what just happened here. Okay, questions? Just not ready? Or is that a yes, I'm good, or I have a question? Yeah. Okay. Here. All right. Cool. If you understand that, then what I'd like you to do is I'd like you to find the mass percentages for copper 2 chloride, silver nitrate, and calcium phosphate. And before you do, let's remind ourselves, this 2 tells us there are how many phosphoruses? 2. There are 2 phosphoruses. How many oxygens? 8 oxygens. And how many calciums? 3. So go ahead and for the next 10 minutes or so, determine the mass percentages of these 3 things. 1 decimal place would be fine.